The art piece that I have chosen to research and talk about in this week's class discussion is present in the form of dance and is known as the Scènes de Ballet, created in 1948. This unique dance was created by great ballet choreographer and composer Sir Frederick Ashton. A little bit of background information about Frederick Ashton. He was born in 1904 in Ecuador, but soon moved to England where he grew up and developed his career. His career first started off with him being just a dancer, but his ideas and passion soon took notice, in which allowed him to become the principal choreographer of England's Royal Ballet. Along with being the head choreographer, he also took the title of being the director of the company for several years. His choreography was known to be elegant and regal, with abstract, full-body movements that demanded his dancers to be very precise. One of the unique aspects about his style of choreography for the ballet was his intention for the dance to be seen and enjoyed from all angles surrounding the stage, so that no matter where someone was sitting, they would be able to see the full movements of the dancers. The ability to see the dance from several different angles is the part that Frederick Ashton was inspired by through science and math. He was familiar with Einstein's concept entitled post-Euclidean dictum, which stated that there are no fixed points in space. Beforehand, the process of the ballet was to be seen from one direct angle, generally what was directly in front of the stage, and if people were sitting at different angles, they missed part of the action and the beauty of the dance from what not being able to see full rotations and the body movements of the dancers. This study from Einstein allowed Frederick Ashton to reconsider just how dance should be seen from the audience, so they may retain the full beauty and purpose of the meaningful choreography. Now to know a little bit more about the math and science behind the dance. The general form of Euclidean is typically taught in geometry, beginning at a high school level, and is known as Euclidean geometry. The concept was discovered around 300 BEC by the Greek mathematician Euclid. His whole idea was to figure out the specific planes in which solid figures laid on by using axioms and theorems. His ideas brought about new ways of thinking in the math community that allowed for true insight into the subject matter and mathematicians and scientists to generalize and reach conclusions from facts. This soon became known as the theory of Euclidean, for which coordinate planes and spaces are made of multiple dimensions, in which the distance between points is measured by generalizing using Pythagorean theorem, since shapes have meaning and exact measurements. Many mathematicians and scientists created postulates, or rules and theorems, as to why certain aspects of the coordinate planes are true. For example, the idea of parallel lines, the parallel postulate was created, which stated that there is a uniqueness to parallel lines, so that no matter what, they will never touch and they will have the same slope. That is the generalization of what Euclid's first idea was, that was developed into several different aspects, such as what Einstein later discovered to further the knowledge and use of Euclid's designs. Frederick Ashton and many other dance choreographers learned from this aspect and used it to transform the way in which dance was perceived by the audience. I have included in this post a video clip of current dancers still learning and performing some of Frederick Ashton's choreography.